Hi everyone, we're going to solve a rational inequality and graph the solution set, and this is the problem we're going to do. The first thing we're going to do is move the 3 over. So we're going to have 4x plus 5 over x plus 2 minus 3 is greater than or equal to 0. Now this is not strict. Let me talk about strict. So this would be a strict inequality. Let me just change it. Let me put it up. This would be a strict inequality, and this is a non-strict inequality because it has an equal. That's just vocabulary. Okay, so the first step we're going to do is we're going to take our, for f of x equals 4x plus 5 over x plus 2 minus 3, we have to find all the zeros of f and also where f is undefined. The first thing we have to do is to simplify this. So what I'm going to do is multiply this 3 by 1. In our case, our 1's going to be x plus 2 over x plus 2 because we need the same common denominator. So that's going to give us, our common denominator is x plus 2, and we're going to have 4x plus 5 minus 3x plus 6. Minus 6, sorry. Remember, you have to distribute the negative. Okay, and we simplify this, and we're going to get x minus 1 over x plus 2. Therefore, my zeros, if we set this to 0, you set your numerator to 0 to get your zeros, and that's going to be 1. And also, it's undefined. You look at your denominator and set that to 0 where it's undefined. That's going to be negative 2. So if you order this, we're going to have negative 2, 1, and the intervals we're going to check are from negative infinity to negative 2, and then negative 2 to 1, and then from 1 to infinity. Okay? So I'm going to write the intervals down. So basically, if you do like a little number line, here we have negative 2, and we have 1. So our intervals are going to be, we want this side of the graph, what's going on with that? That's going to be negative infinity to negative 2. And then we want this portion, what's going on with the graph between negative 2 and 1. And then we want what's going on from 1 to infinity. Okay, so I'm going to do this and choose a number in this interval. I choose a number very close to negative 2, which is negative 3. 0 is always a good choice for that, and I'm just going to choose 2 there. And I'm going to plug it in to my equation. F of x equals 4x plus 5 over x plus 2 minus 3, and you get your values, and f of negative 3 equals 4, f of 0 equals 1/2, and f of 2 equals 1/4. And our conclusion is what we're looking for. This is negative 1/2, sorry. This is going to be positive. 4 is positive. This is going to be negative, and this is positive. So we want ours to be equal to or greater than 0. That means it's positive. So the intervals we're going to choose are these two. So the way you write your solution set is, it's not strict, so numbers must satisfy the equation also as x minus 1 over x plus 2 equals 0. That's what it means not being strict. So our solution set is x such that x is smaller than this one right here, negative 2, or this one, which is, it can equal 1. 1 is greater than, whoops, I should did that wrong. Or x is greater than or equal to 1. Interval notation would be this way: negative infinity to negative 2, or 1 to infinity. Okay, now I'm going to graph, well, I already graphed it, but let me write it down. We have, I'll just use y. Y equals x minus 1 over x plus 2. We already plugged in 0. We can clearly see our y-intercept. If you plug in 0, is 0 minus 1 over 0 plus 2, which gives you negative 1/2. So that's your y-intercept here. When you set y equals 0 to get your x-intercept, you cross multiply, this goes away, so you're just going to get 1 comma 0, which is here. And then we already did some choosing here. When I did negative 2 on the previous slide, that went to 4. You could also pick, I just sketched the graph here. You could also pick other numbers to get a better curve here. And that is your graph. Okay, that's all. Thank you. Have a nice day. Bye-bye.